Here is the truth nobody is telling you. 9 times out of 10, engine idle surging is not a throttle body problem. It is not even close. It is a dirty, failing, or miscommunicating part somewhere else in the system feeding your engine the wrong information. And your engine is reacting exactly the way it should, by hunting for the right mixture and shaking your car apart at every red light. Every day that part sends the wrong signal, your engine runs lean and slowly destroys components that cost 10 times more than the original fix. Most of these parts can be tested at home and fixed for under $10. Here are 13 causes of engine idle surging that most mechanics overlook. We are counting down from 13 to 1, starting with the cheapest $5 fix and building to the most expensive. Stay until the end, because culprit number 1 is responsible for more rough idling, more wasted fuel, and more unnecessary repair bills than almost any other part on your car. Let us get into it. Culprit number 13, the PCV valve. Think of it as a one-way pressure relief door between the inside of your engine and your intake manifold. Every engine produces blow-by gases that slip past the piston rings during combustion. The PCV valve routes those gases back into the intake so they get burned off instead of building up pressure. When this valve gets stuck open, it becomes an uncontrolled pathway, dumping air straight into the intake. Your computer did not account for that extra air. The fuel mixture goes lean, and a lean condition at idle is exactly what produces surging, roughness, and stalling. If it gets clogged, the opposite happens. Pressure builds inside the crankcase, pushes oil past seals, and accelerates the carbon buildup that sent you to the throttle body in the first place. Testing takes 30 seconds. Pull the valve out and shake it. You should hear the internal plunger rattling. Silent means stuck. If it rattles, but you still suspect problems, do the cap test. Engine idling. Pull the PCV hose off and cap the port on the intake side. If the idle smooths out, that is your answer. $5 part. 5-minute test. But here's the part most videos leave out. You replace the PCV valve and the idle is smooth. Few weeks later, the throttle bore clogs again. That means the PCV was the messenger, not the root cause. Excessive blow from worn piston rings is pushing more vapor than even a perfect PCV can handle. A compression test tells you the truth. And those vapors? They end up somewhere much worse. I will show you where in culprit number 6. The next one is the part everybody checks first, and cleaning it sometimes makes your idle worse. Culprit number 12, the throttle body and idle air control. Most people grab a can of cleaner and go straight for the throttle body, but cleaning it can actually make things worse. Over months of carbon buildup, the ECU learned how much extra air to push through a dirty throttle plate. You remove the carbon and the airflow changes, but the computer is still running on the old dirty settings. That mismatch shows up as high idle, surging, or stalling. People skip the relearn. I will cover exactly how to do that in culprit number 9 because it applies to almost every fix in this video. Always use dedicated throttle body cleaner, never brake cleaner. A Honda Civic C owner used brake cleaner and triggered severe idle surges that required a $400 dealer reflash. On older vehicles with cable-operated throttles, there is usually a separate idle air control valve. It lets air bypass the closed throttle plate so the engine can hold idle speed. When it gets carbon fouled, the idle fluctuates at every stoplight. Soak it in carburetor cleaner for 6 hours. Bench test it with a multimeter before reinstalling. If it does not respond, replace it. Under $50. Watch for codes P0505, P0506, P0507. Now here is where diagnosis gets tricky. The next cause produces the exact same symptoms as culprits 13 and 12, but the fix is completely different. Culprit number 11, vacuum leaks. Air is supposed to enter through one path. The mass airflow sensor measures it. The computer calculates fuel from that number. But when air sneaks in through a cracked hose or degraded gasket, it bypasses the sensor entirely. Unmetered air, the same lean surge from culprit 13. But this time, the cause is invisible, and there is no code. Common leak sources are rubber intake hoses hardened from heat, the intake manifold gasket, throttle body gasket, brake booster hose, PCV hoses, injector O, ring seals. On turbocharged vehicles, add intercooler couplings and turbo piping to that list. The cheapest detection method is the spray test. Engine running, spray throttle body cleaner around each vacuum connection and gasket surface. If there is a leak, the spray gets drawn in and RPM rises. But modern computers correct so fast that sometimes you hear nothing. So pair the spray with a scanner showing live short-term fuel trims. If trims shift positive when you spray a particular joint, that is your leak. The gold standard is a smoke machine. Non-toxic smoke goes into the intake with the engine off and escapes at any compromised seal. Most auto parts stores rent them. That $30 rental saves you a $500 diagnostic bill. One more thing about vacuum leaks. The brake booster uses manifold vacuum for power assist. If that diaphragm leaks, it introduces unmetered air and reduces your braking force at the same time. Do not compromise on brakes, ever. The symptoms of the next one change depending on when you last filled up your gas tank. Culprit number 10. The EVAP purge valve. Does your car surge or run rough right after you fill up? Hard to start after refueling? This is probably your answer. The purge valve connects your fuel tank charcoal canister to the intake manifold. It lets captured fuel vapors flow into the intake in controlled doses to get burned off. If the valve gets stuck open, concentrated fuel vapors flood the intake. Right after you fill the tank, the symptoms explode. Hard starts, rich misfires, then the system swings lean. That is why you see P0171 or P0174 lean codes mixed with rich running symptoms. The biggest mistake people make is replacing the purge valve and calling it done. If you habitually top off your gas tank after the pump clicks, you are pushing liquid fuel into a system designed only for vapors. That liquid breaks down the charcoal canister into particles that jam the new valve. Your brand new part fails within weeks. Testing is simple. Apply battery voltage to the valve and listen for a click, then blow through it unpowered. A properly closed valve blocks airflow completely. If air passes through, it is stuck open. Now here is something that will frustrate you. You can fix the right part, and your engine will still surge. The next culprit explains why. Culprit number 9. Your electrical system and the ECU relearn. If your car's electrical foundation is weak, every sensor reading is wrong, and every fix you just did will feel like it did not work, because the computer has not caught up yet. Your ECU memorized fuel trims and throttle positions based on the old fouled-up system. After any repair, the computer needs to figure out the new normal. The quickest relearn is a battery disconnect. Engine off, negative terminal off, wait 15 minutes, reconnect. This clears adaptive data on most vehicles built before 2010. On newer cars, use a scanner-assisted throttle relearn. Honda calls it idle learn. Toyota calls it throttle valve close learning. Some vehicles accept a manual procedure. Key on, engine off, wait 30 seconds, then start and let it idle for 10 minutes without touching anything. The nuclear option is a PCM reflash. Ford released updated calibrations for EcoBoost engines that specifically fixed idle hunting after throttle service. Owners who had tried everything finally got a smooth idle from one software update. But none of that matters if your electrical foundation is weak, and here is why. Corroded battery terminals add resistance that drops voltage to sensors. A weak alternator that cannot hold 13.5 to 14.5 volts causes sensor readings to drift. And the number one overlooked electrical problem is ground connections. Your engine has 3 critical ground straps: battery to chassis, engine block to chassis, engine block to body. 3 connections. That is it. If any of them are corroded or loose, every sensor in your engine is getting garbage data. Chevrolet Silverado owners with the 5.3-liter V8 know this problem intimately. Forum after forum describes a surging idle with no codes across model years from 1999 through 2013, and the fix is almost always corroded ground straps or VVT solenoids. A $3 wire brush on those grounds might be the single most effective thing you do after watching this video. 15 minutes, 0 cost. But it works. The next sensor makes your engine act like it is freezing cold, even at full operating temperature. Culprit number 8. The engine coolant temperature sensor. Your computer uses coolant temperature to adjust almost every aspect of how the engine runs. When the engine is cold, the computer dumps in extra fuel. As it warms up, it gradually reduces fuel to the normal ratio. This sensor is how the computer knows where in that process it should be. When it reads colder than reality, the ECU keeps dumping in cold start fuel indefinitely. Too much fuel, incomplete combustion, carbon fouling the plugs, a rough idle that never smooths out. If it reads hotter than reality, the ECU pulls fuel too early. Hesitation and surging, plus potentially overheating damage because the cooling fans might not activate when they should. There is a sneakier failure mode that almost nobody talks about. Air pockets in the cooling system that form after coolant work or a head gasket seep. The air pocket sits on the sensor tip. The sensor reads the temperature of the air instead of the coolant. The reading bounces erratically. If your surging started after a coolant flush or hose replacement, check for trapped air before you replace anything. Watch for codes P0115 through P0118. Verify the sensor with a multimeter and a temperature chart. If the resistance jumps or sticks, the sensor is bad. Under $30, 20 minutes to replace. Check the thermostat too. If it is stuck partially open, the engine never fully reaches operating temperature. Sometimes the $30 thermostat is the whole answer. If you have done everything so far and the idle is still off, this next sensor could be the entire reason. It gets dirty so slowly, you never notice the power loss, until one day you clean it and realize what you have been missing for years. Culprit number 7. The MAF and MAP sensors. Your mass airflow sensor sits in the intake tube between the air filter box and the throttle body. It measures the exact mass of air entering the engine. Every time a cylinder fires, the injector opens for a duration calculated from what the MAF reports. When the MAF gets dirty from microscopic oil particles and dust that sneak past the air filter, it underreports airflow. The computer shortchanges the fuel supply across the board. Every cylinder runs lean simultaneously. You feel it as a persistent vibration at idle, along with reduced power and worse fuel economy. And here is the problem. A dirty MAF almost never throws a check engine light. The computer compensates by increasing fuel trim. If your scanner shows long-term fuel trim above plus 10%, your MAF is almost certainly dirty. Cleaning takes 15 minutes. You need a can of MAF sensor cleaner, not throttle body cleaner, not brake cleaner. Those tiny wires inside are so delicate that the wrong spray kills them instantly. Remove the sensor, spray the elements. Do not touch them. Do not wipe them. Air dry for 15 minutes. Reinstall. Toyota Camry and Honda Accord owners with the 2.5-liter 4-cylinder see this constantly after 70,000 miles. If your car has more than 60,000 miles and you have never cleaned the MAF, it is very likely contributing to your surging right now. If this video is already giving you answers you have been searching for, drop a like. It helps other people with this exact problem find the real answer faster. If your vehicle uses a MAP sensor instead of a MAF, you test it differently. The MAP reads intake manifold pressure. A failing MAP misreports vacuum, so the computer calculates wrong air density. Clean the MAP sensor port and vacuum line. Check for cracked hoses. On turbocharged vehicles, confirm the MAP sensor range matches the boost pressure. Everything so far you can fix in an afternoon. This next one is different. It has been building inside your engine for years, with no warning light and no code. Culprit number 6. Carbon buildup on direct injection engines. If you have a direct injection engine, and most cars built after 2012 do, pay attention. On traditional engines, fuel washes over the back of the intake valve every combustion cycle. Gasoline is a natural solvent. It keeps those valves clean. Direct injection changed everything. Fuel is injected directly into the combustion chamber. It never touches the back of the intake valve. Those valves sit there getting bathed in hot oil vapors from the PCV system and EGR soot, with nothing to wash them clean. Those PCV vapors from culprit number 13, this is where they end up. Layer after layer of carbon, piling up over 30 to 60,000 miles. At first, you notice nothing. Then a subtle roughness at idle. Then slight hesitation under acceleration. Then misfires start appearing. Cold starts get worse. Fuel economy drops. The symptoms creep in so gradually that most owners do not realize how much performance they have lost until the valves are cleaned. That moment is like night and day. If you are thinking your engine feels fine, remember this has been building for 30,000 miles before you noticed. There is almost never a check engine light until the deposits cause persistent misfires. By that point, you might have 40,000 miles of buildup, and the only way to remove it is mechanical. The gold standard is walnut shell blasting. A technician removes the intake manifold and blasts crushed walnut shell media against the valve surfaces. Cost runs between $500 and $800. On BMW N54, N55, or Ford EcoBoost engines, this is routine maintenance at 60,000-mile intervals. An oil catch can on the PCV line slows the buildup significantly. Ford eventually redesigned the 2018 and newer EcoBoost with both port and direct injection, specifically to wash the valves. That tells you how serious this problem is. 5 to go. And from here, a basic OBD2 scanner becomes your best friend. Culprit number 5. The throttle position sensor. Your TPS might be lying to your computer right now, and it will not throw a code until the problem gets really bad. The TPS reports throttle plate angle as a voltage signal. At idle, around 0.6 to 0.7 volts. Wide open throttle, around 4.5 volts. That voltage should climb smoothly. No jumps, no dead spots. When the sensor wears internally, you get tiny voltage jumps that create wild rate of change values. The computer sees rapid throttle movement, even though the pedal is sitting still. That triggers aggressive fuel corrections during what should be a steady idle. Before you replace the TPS, check the wiring first. Corrosion on connectors and frayed wires near the exhaust manifold create the same symptoms as a bad sensor. Same principle as those ground connections from culprit 9. A corroded connector can mimic a failed sensor. That is a free fix. Watch for codes P0122, P0222, P2135. Most newer car owners forget this next part exists, but when it sticks open, the symptoms look exactly like a vacuum leak. Culprit number 4, the EGR valve. The exhaust gas recirculation valve routes exhaust back into the intake to reduce emissions. At cruising speed, that is fine. But at idle, the EGR should be completely closed. Exhaust gas at idle dilutes the intake charge and makes combustion unstable. When it sticks open, you get rough idle and stalling with no lean codes. That is the tell. Quick test. Grab a vacuum pump. Apply vacuum to the EGR diaphragm with the engine idling. If the engine stumbles or dies, the valve is responding correctly. If nothing happens, the valve is stuck or the passages are clogged. Check that the diaphragm holds vacuum without bleeding down. If it leaks, replace it. $40 to $150. Culprit number 3. Ignition coils and spark plugs. If you have been chasing sensors and parts for months with no improvement, this might be your answer. That Honda S2000 owner had low idle on cold starts and progressive bogging. He cleaned the idle air control valve, made it worse. Cleaned the throttle body, still worse. Replaced the idle valve entirely, still worse. $600 later, the real problem was faulty ignition coils. Replacing them fixed it immediately. All those other parts were fine. The coil swap test is your best friend here. Move the suspected bad coil to a different cylinder. If the misfire follows the coil, you found it. If it stays on the original cylinder, the problem is the plug, the injector, or something mechanical. Spark plug condition tells its own story. Wet or fouled plugs mean too much fuel or leaking injectors. Clean white plugs suggest lean operation. Check the plug gap against manufacturer spec. Heat-dependent coil failure is particularly tricky. The coil works fine cold. As it warms up, insulation breaks down, and it starts misfiring intermittently. A multimeter will not catch this. If your surging only appears after 15 or 20 minutes of driving, suspect the coils first. We are down to the final 2. These deal with parts most backyard mechanics never touch, but they cause a disproportionate number of idle surge cases on vehicles over 100,000 miles. Culprit number 2. The crankshaft position sensor and variable valve timing solenoids. The crankshaft position sensor tells the computer the exact rotational position and speed of the crankshaft. Without a clean signal, ignition timing is wrong, fuel injection timing is wrong, and the engine cannot hold a stable idle. Period. CPS failures often get worse with heat and vibration, making them almost impossible to catch during a quick shop visit when the engine is cold. If your surging only happens after full warm-up and you have checked everything else, the CPS should be your next suspect. Check for code P0335. Variable valve timing solenoids control camshaft phasing. When they get clogged with sludge from overdue oil changes, they cannot hit the commanded position. Watch for codes P0011, P0012, P0014, P0018. Clean the solenoid screens. If cleaning does not work, replace the solenoid. $50 to $150. VVT solenoid problems are almost always caused by poor oil maintenance. This last culprit bundles 3 components together. Each one can mimic everything else we have covered. Culprit number 1. The AC compressor, oxygen sensors, and fuel injectors. If your engine only surges when the AC kicks on, you probably think the AC is the problem. It is usually not. It is what the AC reveals about your electrical system. When the AC compressor clutch engages, it puts an immediate mechanical load on the engine. A small RPM dip is normal, but if the compressor short cycles from low refrigerant, those repeated sudden load changes overwhelm the idle control system. On a vehicle with weak electrical foundations, remember culprit 9, that current draw exposes everything. Voltage drops, sensors drift, the idle collapses. Check alternator output and battery voltage under AC load. That single test tells you whether it is an AC problem or an electrical one. Now, the oxygen sensors. Your upstream O2 sensors tell the computer whether the mixture is rich or lean. The computer adjusts injection hundreds of times per minute based on this feedback. When an O2 sensor gets sluggish, the computer overcompensates, then corrects, then overcompensates again. Experienced mechanics call it the O2 dance. Diagnostic trick. Temporarily unplug the upstream O2 sensor. If the idle smooths out, the sensor is contributing to the instability. This is a diagnostic test, not a permanent fix. When replacing O2 sensors, use OEM or direct fit. Aftermarket universal sensors often have different switching speeds that create new problems, and use penetrating oil before removal. Corroded threads snap sensors and turn a $200 job into an $800 exhaust manifold repair. Finally, fuel injectors. Dirty injectors starve individual cylinders. Leaking injectors flood them, foul plugs, and dilute your engine oil with raw gasoline. You will smell it on the dipstick. That gasoline contamination is eating your bearings right now, and most people have no idea. But before you touch injectors, check fuel rail pressure first. If pressure is low from a weak pump or clogged filter, fixing the supply side may resolve everything. That is a $60 fuel filter fix versus a $300 injector cleaning. Always check pressure first. Now, here is your game plan. Start with the free stuff. Ground straps, battery terminals, alternator voltage under load, then the $5 PCV valve and a $10 MAF cleaning. Those two alone solve the majority of cases. Next, spray test for vacuum leaks. Blow test the EVAP purge valve and stop topping off your gas tank. Then clean the throttle body and do the relearn, but only after those upstream fixes are done. If the surge is still there, move to sensor and ignition checks. Live data, coolant temp, TPS sweep, coil swap test, O2 unplug test. Direct injection engines over 50,000 miles. Budget for a walnut blast. All of that for under $100. Shops charge $300 to $1,500 for the same work. You now know the 13 culprits behind engine idle surging. If your car is surging, start with the ground straps. If it works, drop a comment below. Those comments help others find the answer faster. If this gave you real answers, subscribe and share this with someone whose car has been surging. You might save them $1,500. But here is the thing. Every culprit we just covered, the carbon buildup, the clogged PCV, the dirty MAF, the sludged VVT solenoids, they all come back if your maintenance is wrong. I made a video that covers the exact habits that prevent all 13 of these from ever developing. Watch it next.